Good afternoon, Robert Scribbler. It is August 15th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now for this segment, I'm going to follow up on a previous video blog from yesterday that focused in on some potentially damaging climate impacts from human-caused climate change, and which in general focused on impacts from sea level rise. Now, sea level rise is one of the primary contributors to damage from human-caused climate change. And the reason for this is that it is such a widespread influence that impacts so many coastal cities and communities around the globe. And as sea level rises, damages multiply. Presently, nuisance flooding, increased instances of tidal flooding, and increased damage from a higher base for storms when they do run into the coast is impacting communities around the world. But I want to go ahead and just drill down and give you guys an idea of sea level rise risks as a global signal. Now, presently, the global ocean is rising on average at a rate of 3.3 millimeters per year if you're taking in the January 1993 to May 2017 timeframe. Now, as you get closer to the present day, say for example, if you take the last 10 years, we get closer to a 4 millimeter per year rate of rise globally. And as global temperatures warm, particularly as they get into the range of about 1.5 C to 2.5 degrees Celsius above 1880s averages, then we start to see a risk of far more rapid sea level rise and a multiplication of the damages that we already see now due to rising global ocean levels. So looking at this graph, we see that there is, looking at this map, we see that there is a degree of variation in global sea level rise. If you're looking at, say for example, yellow, just flat yellow, you're looking at maybe about a 2 to 3 millimeter per year rate of sea level rise. And that's where we see in most cases globally since 1993. In some regions, though, we see sea level rise tipping into the orange to red zone, and that's getting into 5 to close to 10 millimeters per year in some locations. Now, also, we do see some regions like the near coastal waters of the west coast of Greenland and some regions in the Arctic and some regions down here near Antarctica that actually show a negative trend for sea level. Now, these regions that show a negative trend for sea level are rare, and there are a couple of reasons why we see that. I'd also like to note that one reason where we see a negative trend for sea level rise is also the Caspian Sea here. And the reason why the Caspian Sea is falling is one is because it's not connected to the global ocean system, and two, because increased evaporation due to warming in this region is drying out the Caspian Sea, as well as changes to the way water flows into the Caspian Sea due to local farming. So why do we see counter-trend reductions in sea level in small zones? Well, one reason is current change. If currents change, then it can create a different stress on the ocean surface, a different forcing on the ocean surface, and you can see sea levels drop. And we see this near the Gulf Stream and near some of the currents near Japan. Also, one of the reasons why we can see sea level reduction is that as ice melts from glacier systems in places like Antarctica and Greenland, it creates a loss of gravitational pull in this region, which causes seas to relatively subside. But as you get further away from the immediate zone of mass loss, then the sea level rise signal again ramps up. Now, a lot of talk has been made about the gravitational effect on sea level rise. In fact, for most coastal regions around the world, the gravitational effect is blunted because you get glacial melt from Greenland, glacial melt from Antarctica, thermal expansion of the world oceans, and glacial melt from mountains around the world. So there's a local gravitational effect, but as you can see, for most regions, despite the gravitational effect, seas are rising. Now, there's other reasons why sea level rise might be blunted, and that involves crustal rebound, which is still ongoing due to the loss of, for example, the Laurentide ice sheet in North America, or reduced ice mass on Greenland, which can cause crustal plates to tilt. And the thing is that what this causes is subsidence in some regions, like the eastern seaboard of the US and the southeast, and in Florida, you have subsidence due to crustal rebound. And in certain regions like the coast of Alaska, you have land rise. Now, this subsidence and land rise is on the scale of usually about 1 to 2 millimeters per year at most. So if global seas are rising at a rate of 3 to 4 millimeters per year or more, and we're looking at more in the coming decades if global temperatures continue to rise and fossil fuel burning continues to drive that rise, then subsidence and crustal rebound become less apparent in the measure and less of a signal. So to sum up, overall, globally, in most regions, seas are rising and is an issue for the vast majority of coastal regions around the world. The primary driver of this is glacial melt and thermal expansion, both due to global warming and human-caused climate change. And if you're living on the coast in practically any region of the world, with a few minor exceptions, you should be concerned about sea level rise. Now, East Coast maybe more so than West Coast of the US, near Australia maybe more so than the coastal regions of British Columbia and Alaska, but overall, everywhere, pretty much everywhere on the coast is at risk. So thank you for joining me, and I'll be chatting with you soon.